It's a great pleasure to introduce this session. For me, partly because it seems to be a perfect amalgamation of the two sponsors, as it were, of this conference. The topic is intangibles, and this session is about the measurement and definition of them, which is a key theme for ESCoE. Before we start, just to say that the speakers will speak for 15 minutes, then we'll switch to the discussants who will have 5 minutes, and then there will be 10 minutes for questions and answers. Could I please suggest, and then we'll switch to the next speaker. Could I please suggest that you keep your questions to the end and of each presentation. And could you please also introduce yourselves so that if we don't have time, then you will be able to have a bilateral later on. And I have been told that I need to strictly keep to time. So if I do cut you off, I apologize in advance, but we need to keep to time. Thank you very much. It gives me great pleasure now to welcome Josh for the first presentation.
Okay. Good. Hello, everyone. My name is Josh Martin. I'm the head of the productivity team at the UK Office for National Statistics. It's a pleasure to be here. I'm going to talk about some joint work that I do with a colleague, Kane Babert, who's not here today, on the challenges measuring intangible investment through surveys. Been doing this work for quite a while. I actually promised Rebecca back in 2017 that we were doing this and it'd be done by Christmas. Of 2017, the exuberance of youth, I think, and in my old age, we've actually now finally finished it. We also wanted a sort of slightly controversial title. I like doing that sort of thing. So the F words, read into that what you will. It's definitely difficult. So the start of this work is with the investment in intangible assets survey, which the ONS ran over a decade now, decade ago now, and some people in the audience were involved in that work back then. It was the first, I think, of its kind to ask businesses about the full set, or almost the full set, of intangible assets that are included in the sort of broader framework that Dan was taking us through earlier on. And the survey questions looked a little bit like this. So for 6 asset categories, it had a set of questions asking businesses, first, did you do any of this sort of investment or not? Yes or no? And if you did, can you please write down how much you did in terms of purchased investments, how much investment you made by buying from other businesses, and how much you did in-house. And also, interestingly, and I think, again, rather uniquely, asked about how long the business would expect to benefit from that asset in years and months, as a measure of a service life, and therefore to inform a depreciation rate. This sort of style of survey was repeated in the UK a couple of years later, and in Italy and elsewhere in the subsequent years, although it hasn't been repeated at the ONS since then. So it's just a sort of two-off survey. Despite the impressive nature of the survey design and the effort to run such a thing, the results were perhaps a little surprising and a little disappointing in a way. This chart compares the estimates that you get from the survey in blue with confidence intervals with the estimates of investment that are in the current ONS macro-based set of estimates of intangible investment, which were published earlier this year, which use sort of a range of national accounting data and modeling and so forth. And you can see that they are quite starkly different, particularly for the 2 assets at the bottom. So for R&D and software, those assets that are in the national accounts, the numbers in the survey were lower, although about half perhaps the value of the national accounts estimates. For the uncapitalized intangible assets, the other 4, the numbers are quite substantially below what those macro estimates make. So perhaps one of them is wrong, or perhaps they're measuring a different topic. But in any case, we need to understand why those survey data give us such different results to the macro estimates. If we want to use those surveys to understand intangibles, and yet they're telling us a different story to our other set of intangible investment estimates, we need to understand why. And it could be that the survey and the macro estimates just don't align, or it could be something to do with the survey itself and the way that businesses respond to that survey that is in some way problematic. So what we set out to find out in this work is, why is it so difficult to collect data about intangibles from businesses on business surveys? And this is a sort of set of characteristics of intangibles that make it so hard, we think. Firstly, intangibles are intangible, that sort of goes without saying, but because a business can't see them, feel them, touch them, it might be quite easy for a business to overlook intangible assets when they're responding to a survey. If they get asked how many new transport equipment vehicles they purchased in the last year, they might be able to look out to their car park or their fleet and count them even. They're salient, they're visible, they would remind them to include them on the survey. Intangible assets don't have that property. Businesses will only typically be able to respond to questions on a survey where they actually have the data. If they don't, then it's going to be an estimate at best and a nil return at worst. And if they don't hold the data on intangible investment, therefore the responses are going to be quite poor. And because businesses don't have to report this sort of stuff in business accounting, following international financial accounting rules, and they're not often asked on business surveys by national statistical institutes, there's not much incentive for the business to keep that data, and therefore the chance of them actually being able to respond about it are quite low. The concepts as well need to be familiar to respondents. They need to know what we're asking in order to be able to give a response, ideally to give the response that we expect, but to give a response at all. If we ask them about organizational capital and they don't have a clue what organizational capital is, then they probably won't be able to respond about it. So if the concepts are unfamiliar to them, that's a problem. The concepts are also somewhat unfamiliar to us as the researchers. They can be different across research teams, between those macro estimates and the survey-based measures. So unfamiliarity of the concepts is challenging all round. Intangibles, as the discussion earlier on sort of alluded to, is often created on own accounts, made by businesses for businesses. They don't buy it in a transaction in the market. That's quite unlike tangible assets, like cars, where business is unlikely to make one itself, it's more likely to buy one. And if you buy one, you've got a transaction price, and it's easy to record its value. When it's created on own account, national statistical institutes generally need to sort of model the value of these sorts of investments, and asking the business to do that sort of complex computation on a survey is going to be challenging as well. And valuation as a result is difficult, but it's also made more difficult by the sorts of ways that businesses record intellectual property across multinational units, and the sort of artificial values that comes with that at times. So we look at all of these characteristics and we try to synthesize them down to 4 F words that we think help to contextualize this problem. So we say that intangibles are easily forgotten. We're not putting it at the feet of businesses that they're forgetting anything, but rather it is easy to overlook and therefore forget about doing intangible investments. The definitions are fuzzy, both to the businesses and to us, the researchers. The framing of the question might be important. That's quite usually true on surveys, but maybe particularly the case here. Intangible investment surveys are often done under the auspices of innovation surveys or research surveys, and that might prompt businesses to give a certain type of response rather than a sort of official investment surveys. And the frequency of the survey might be particularly important because there's a lot of investment done on own account, which tends to be sort of iterative or repetitive or continuous. Asking a business to sort of partition that investment into a 3-month or a 12-month period might be difficult for them to even figure out sort of what was happening over the course of those periods, as compared to a transaction on the market where they've got a definitive purchase date and value. So that's the sort of tenet of our argument, is that these are the characteristics of intangibles that make it difficult to measure. I'm going to present some evidence that supports, I think, these characteristics, and then some ideas for making a survey better in the future. So firstly, forgotten. The ONS survey from 2009 did a comparison at the record level between respondents on that intangible assets survey and respondents to the UK Innovation Survey. That's the UK implementation of the Community Innovation Survey, which is conducted across Europe and does collect some vaguely similar data on investment in intangible-like expenditures. At the time, the authors were only able to compare with the UK Innovation Survey from 2 years prior to their survey. And so they speculated that the poor degree of congruency between those two sets of data was because of a mismatch in timing. So we've updated that analysis to compare it with the contemporaneous innovation survey, and then also compared the later ONS survey with the contemporaneous innovation survey. And what we find is that an enormous proportion of businesses report inconsistently across those two surveys. So this is 60 to 80 to 90% of businesses cannot correctly respond across two surveys that they either did or didn't invest in an asset. This says nothing about the value of that asset, value of that investment, simply that it must be non-zero in both surveys. And the vast majority of businesses can't get that consistent. So for me, that's suggestive that they forget about those sorts of investments. This won't show the charts here, but this is also true in lots of other cross-survey comparisons that are documented in the paper. So moving on to that concept of fuzzy, I've already shown you this chart, which I think demonstrates the fuzziness of the concepts. But even more so than that, if you actually look at the survey questions themselves, the descriptions, the inclusions, the exclusions, the guidance giving around them is very different across different surveys. So it's no wonder that businesses will give different responses. This is the survey question from the annual business survey, telling businesses how to respond about investment in software and databases. It's got some inclusions and exclusions. It gives some examples. It asks for a breakdown between own account and purchased. That's, you would think a reasonable amount of support. If we look at the quarterly capital investment survey, it's similar. We've got inclusions, not exclusions. The word database has been dropped here. So it's perhaps a little less helpful than the annual business survey. This was the investment in intangible assets survey, lots more detail, inclusions and exclusions and lots more guidance. There's also that note in blue saying estimates based on proportions of staff time are acceptable. Indeed, that's what the NSIs use to estimate own account investment. So no wonder it's acceptable here. That's not something that was included on the previous surveys. And this is the innovation survey, which lumps software in with advanced machinery and equipment. So again, no wonder you get different responses. You're asking different questions. These concepts are fuzzy across these different surveys. To look at the framing, we can look at how consistency within a survey compares to consistency between surveys. So again, thinking about that record level matching of businesses, if you match businesses between the innovation survey and the official R&D survey, you get a consistency in the sort of investment estimates that they report, which is the orange dots on here, that is sort of middling, 0.6, 0.3 in one case, 0.8 in some other cases. So it's a reasonable consistency in the sort of values that they report for the same year. The blue line shows that the within survey consistency between adjacent years of the R&D survey. So businesses are much better able to report consistently within a survey. They're sort of conditioned to respond consistently over time within a survey rather than across two different surveys, even where they're conducted in the same year. So there's something about the framing, maybe the fact that it is an explicit R&D survey that prompts businesses to give more consistent responses. Maybe businesses even, and we know this to be the case, set up internal data management systems so that they can respond to these surveys consistently over time. They know what data they're going to be asked for. Finally, the frequency. So we compared responses on the annual business survey with the quarterly capital survey, aggregating the quarters up to years. And in fact, we limited this only to businesses that have been sampled in all 4 quarters of the quarterly capital survey in order to be able to compare them with an annual survey. The sort of levels of investment that they report in the quarterly survey and the annual survey are often quite different. And the red bars here are purchase software. We've got businesses reporting a lot more investment in the quarterly survey on purchase software than they do in the annual survey. The opposite is true for buildings and structures and own account software, where they actually report less in the quarterly survey than they do in the annual survey. Machinery and equipment seems to be much better aligned. So I'm likely to go over time, but I just want to say a few words on what we can do better if indeed we think there is this problem. We think rather than organize these sort of questions by asset, we could organize them by data type. Within an asset, if we're asking for purchased investments and own account investments, that's possibly needs to go to the finance department for their expenditure data, and to the IT department, say for own account software, for those who know about the actual occupations involved in creating assets. So rather than structure it by software, which is potentially two or multiple people in the business, structure it by where the data is going to come from, and give them guidance on where in the business that data is likely to be held, if at all. That will probably require some research. We could collect more components rather than totals, rather than just say, tell us about own account investment. Ask them, how many designers did you have? How long did the designers on average spend doing own account design, and what were their average wages? Let the NSIs do that complex calculation rather than asking the business to do it, since they don't really have the skills. We should provide more clarity where helpful, but leave open things that are less clear, perhaps. Allow more flexibility in timings. If it's difficult for a business to respond on a 12-month period, don't force them. Let them respond on something that is, suits their reporting schedules, and we can adjust it at our end if necessary. We need to solidify definitions within the research community, so we're all asking the same questions. That'll help the businesses as well. And we simply need to do more testing, because we are not businesses. We don't really know how they're going to respond and interpret this stuff. So you could think about a survey that looks a little bit more like this. You could have color coding of different questions to orient them to where in the business the data is likely to come from. You could give them guidance on where they need to go and look. You could invite them to use whichever reporting period works best for them, and so on and so forth. Thank you.
Good morning, and thank you for inviting me to this conference. I'm Gagana Nwano, and I work for the Cabinet Office. And you might wonder, what's my stake in this pie? It is because I worked at ONS, and with Jonathan Haskell and other colleagues worked on the first intangible asset survey that ONS did over a decade ago. In terms of the paper that Josh and Kane have done, I think firstly, I would like to commend them for the research that they've done in terms of the issues with measurement of intangible assets. I think Dan mentioned rightly that there is, a lot in terms of trying to get this right, and I think a lot of the research has definitely shown the value of intangibles, and Dan's kind of Google chart earlier showed about 30,000 research papers, in the last few years. I'm sure many of them were in support rather than kind of showing that intangibles weren't of value. So I think there's a lot of research that has definitely shown the value of intangibles to the economy, to productivity, and all of that. So just coming back to Josh and Kane's paper, I think they've rightly kind of identified, and summarized the issues with measurements using the 4 Fs: forgotten, framing, fuzzy, and frequency. And I'd like to just paraphrase a few of these. So just, thinking about forgotten, it's really about, asking businesses what they, as Josh said, what they routinely don't collect, what they routinely don't think about in terms of, their operations and their processes. and it's difficult to kind of get and elicit a right response. And I think part of the descriptions and the instructions on the survey says that, you know, businesses can estimate and provide an estimate if they don't have the right numbers. But if I can draw on the experience that I had developing the management and expectation survey with Rebecca Riley and John Van Reen and Nick Bloom and other colleagues, businesses don't want to guess things if they don't know. They like to be asked things that they don't know. And when we're doing kind of a follow-up with businesses about why they didn't provide any responses to some of the questions on uncertainty, and again, that's another tricky one. We're trying to measure what businesses don't know. Their response was that, you know, they didn't provide any response because they were uncertain about about the answers. So technically, businesses don't like to be asked things that they don't know, and if you do that, you're unlikely to elicit an answer from them that will be either correct or reasonable, or they might just end up not providing you with anything at all. So I think I agree with Josh's recommendation about probably thinking about focusing on what businesses know. So what can we measure? They can measure how many staff they have, how many staff are working on specific, you know, intangibles, you know, what they're paid and all of that. But I think there's another fundamental issue, which is about, I think, as Dan also mentioned earlier today, bridging the gap between research and experimental work and formally collecting information as, you know, as a formal statistic. And I think that's where I probably don't know where the link is, and maybe something we need to, you know, think about more, because Dan, as you've shown, there's a lag between, you know, the research and they're being formalized into you know, into the statistical or national accounting process. And I'm kind of just a bit curious as to how do we make the link? How do we bridge the link? Is there a formal link? What's the process to do that? Because I think a lot of the gains in some of the recommendations that, or rather all of the recommendations that Josh has provided, which I totally agree with, is about having the is about having the finance, having the financial backing to actually carry out the testing. So do more testing, definitely, but you need to finance it. And I think unless NSIs and NSOs have the backing to actually make this priority, then it's not likely that they will be able to provide the financing to actually do a lot of the research and testing what the method was, the right methodology to get this right. So I think there's that aspect, which I think it would be good, maybe, I don't know if the ESCoE or the ONS or some of the colleagues here, you know, could pick up, but there's definitely, you know, an aspect of how do we bridge that gap? How do we bring these intangibles from experimental to mainstream, and then start to get, you know, the financial backing, the financial investment to actually implement these tests and to actually learn and improve and modify the, you know, the collection methodology until we get to a place where we can say, yes, we've actually, you know, reached a point where we are comfortable with the methodology, and, you know, we can move on to the long list of new intangibles that I think Dan has shown us some in the first presentation, because I think otherwise we'll just have a backlog which will just keep growing, and we might not be able to move things further until we're able to bridge that divide between experimental and regular routine statistical production. Thank you.
Hugo de Bond, Statistics Netherlands. Thanks a lot for that very informational presentation. My question is can you comment on the difference between manufacturing and services? So if you think about product improvement is a very deliberate process in terms of manufacturing. It might take some time, so they're more keenly aware of that they're actually improving. And if you look at services, for instance, selling things on a website is more an ongoing daily process, and they might therefore not be aware of the fact that they're improving. Thanks.
Is it still working? So I think it's a really good question. Thanks very much. We didn't look at industry differences in consistency, but we definitely should. I think you're right that that's a plausible explanation, that some types of businesses who do some types of activity are likely to be more consistent in some areas and less in others. If manufacturing are indeed more consistent on something like design, then they may be less consistent on something like training. So that might give us some explanations in some areas, but probably doesn't explain everything. I don't think there's ever going to be a business that is sort of perfectly matched up on all of these things, or I doubt it anyway. And if you think back to the chart that I showed of the different scales of investment between the survey-based measures and the macro measures, even if manufacturing was consistent, there's still a very big gap between the different types of measurement. So a good question, but I doubt it's a sort of a silver bullet in terms of persuading businesses to respond correctly.
Thank you very much, Josh. Being involved a little bit in the design of the earlier survey with our good friend Tony Clayton as well, who I should mention, the thing that struck us was exactly the problem that Dan Sickle was talking about earlier on, namely the own account and asking firms about their own account. However, I have to say that when we went to the firms, they have loads of management accounts. And if you go to a firm, I don't know, full of designers, they've got time studies where they expect the junior designers to spend, 80% of their time on design, and the more senior designers to spend 80% of their time on pitching and all that kind of thing. So, but my feeling, having walked away from some of the pilots that we did before the survey, is that somehow if we could bridge the gap between asking surveys and the internal management accounts which firms keep, we could actually get quite a good measure, in fact, certainly of the labor types of inputs to these things. We then have the difficulty about marking all of those things up. But its comment really, it's bridging that gap, I think, would be a really helpful way forward to get us to the position of what you described and what Dan was describing earlier on. Thanks.
Yeah, thanks, Jonathan. That sounds really hopeful. I think in that case, we either need to tell businesses where they might go and find that data for themselves, so they can make the connection between the survey question and that data they do hold, or indeed ask them for manageable data chunks. How many designers do you have? What were the time fractions? Let us do those calculations rather than rely on them to do that sort of thing. That'll probably make it more transparent for us as well and useful, and also avoid any error at their end. But it's good to hear that businesses might hold some of that data.
Richard Hayes, ONS. Always good to hear someone from the Cabinet Office suggesting, yes, I should get more money, but don't worry, I won't hold you to that, Gags. My thought here, particularly around the point that Gagnon was raising around firms not liking to return data they're uncertain about, and Josh's point about fuzzy, is there a necessary first step here of working with business accounting bodies in terms of thinking about how they define some of these components, as well as the way that at sort of national accounts level, we define some of these, because giving firms a single unified set of metrics on which to report, effectively picking up on Jonathan's point around management accounts, giving a common conceptual frame may be a first step to solving some of these problems.
You want to say something as well? I think working with business accounting is a really good idea.
Yeah, Richard, I totally agree with you. And I think there's a role probably for the NSOs to define, the formal definition and the formal framework for some of these. And I want to assume that they do it in consultation with researchers, in consultation with accounting bodies. So yes, there is that first step. I think the main question is who's going to lead it, and it might be the NSOs, but I think until it kind of gets enough priority that this is really something that they should focus on and dedicate resources to, then it might not be able, it might not come through quickly enough.
Thank you very much. And now we will switch to Leonard, please. Thank you.
Hi, it's great to be here. I really want to thank the organizers for selecting this paper. It's really given me an opportunity to explore some ideas, and I'm still very much in the exploratory stage of this paper, so I'm looking forward to your comments and questions. I'm emeritus at the Federal Reserve Bank of Philadelphia, and these are my opinions and not those of the Federal Reserve System. So this is an extraordinary time that we're in. And what we see is, particularly through the lens of the stock market, R&D kind of taking over the world. And what I'm trying to do in this paper is to think about how could that be happening when R&D is just a couple of % of GDP. And these firms that are gaining so much market value, Apple, Google, and so forth, have done extraordinary things to what we are capable of over the last 15 years. And these innovations have taken place in practically every dimension of human endeavor, from software to entertainment to biology to electrical batteries and the rapid change in the very markets that we transact on. So when we study intangibles, we're venturing into the heart of this tumultuous creativity, and that, to say the least, is not easy. And we try to domesticate intangibles, and one way we do that is we view intangible investments as being rather similar to tangible investments. But is that really the right way to look at things? Dan did such a great job of setting this up when he talked about non-rivalness and the fact that there's a zero cost of reproduction. So intangibles become like water very quickly. Of course, there's IP protection that creates a stream of revenues, but that's sometimes refused, as with open source or with household innovation. There's no physical deterioration to intangibles because it isn't physical, and there are no geographical ties. We think it's easy to think of a tangible asset as being located in one place, but intangible assets can be anywhere. To a very large extent, R&D is not done at arm's length, and its output is highly risky with very fat tails. The activity of R&D is never the same from period to period. The whole point of research and development is that you're constantly doing something new. So all these make them rather different from, say, a truck in terms of trying to count it or price it. So I'm trying to think about how it is we deflate intangibles. And by and large, we do this by deflating its input costs and add back in an overall estimate of productivity. And what that does is it captures the opportunity cost of the intangible. But it doesn't really tell us what the real value is in the sense that of a tangible. And because we don't observe transactions prices for R&D, it's very hard to get at a price. All we get is a transaction price for the products that are created. And then, so there's this difficult relationship between the products that are created and the intangible investment stream of investments. And finally, the innovative products that I'm about to talk about are both outputs of innovation, but also inputs into innovation. Tangible investments like a computer or communications equipment can fall rapidly in price. Why is that not true of the intangible investments, say the intangible investments that lead to the rapid fall in price of computers and telecommunications equipment? So one way of thinking about this is that the depreciation rates for research and development, which are very fast, are telling us about something about technological progress that is a gain rather than a loss. And this is something that the Q&A went into earlier. And so, if you have an intellectual product, like a pharmaceutical product, when it runs out of its intellectual property protection, when the patent expires, you lose private value. The corporation that created it no longer is earning a huge stream of profits from it, but the intangible still exists in a social or public sense. The rapid depreciation rates that we attribute to R&D are an indication that we may have double-digit rates of technological progress. Now, I'm sorry, this is rather hard to see, but this shows you depreciation rates across the industries that do most of the R&D, and they have depreciation rates that run from 7% to 40%. So some very rapid depreciation rates indeed. Now, our depreciation rates numbers are not very good. If you look at the literature, the results are all over the map. So let's actually look at some individual processes or things that are actually happening out there, things like space launches, robot scientists, cloud computing, neurology, biochemistry, sensors. All these inputs to experimentation are decreasing in price pretty rapidly. So let's think about the central drivers of innovation that lay behind our response to the pandemic, right? So one thing people have said is that the 21st century is the century of biology. And so let's think about what biology is all about. The central dogma of biology is that DNA instructs RNA. Those instructions are about how to create proteins. And the proteins fold into three-dimensional shapes. And most of what a protein actually does is based upon its three-dimensional shape. So DNA sequencing of one human genome, we didn't get the first one until 1999. In 2005, it still cost $10 million to sequence a human genome. I think in that year, we sequenced one human genome. In 2018, they cost $1,000 each, and we're doing this by the hundreds of thousands, if not millions. 47% annual rate of price decrease, much faster than Moore's law that powered the last half of the 20th century. DNA manipulation. From 2012 to 2018, we discovered the CRISPR family for manipulating genomes that brought down the price of DNA manipulation 150-fold and made it available to every laboratory in the United States. Think about protein folding. This past year, DeepMind AI technology solved protein folding for 2/3 of all the proteins that we know about. In principle, they haven't actually done it, but they have estimated that they have a methodology to very accurately determine the folding for 2/3. So the top line here, the white line is Moore's law, and it's which we think of as being very, very fast. But the cost of the human genome follows the green line much, much faster. So what are other examples? Well, there's Moore's law, 29% rate of price decline, cloud computing prices, 7% price decline, rocket cost per flight fell by 3 times, 13%. And we went from an era where, space travel was getting kind of moribund to an era in which space commercialization is sweeping the globe. LEDs, LED light bulbs are incredibly efficient use of electricity compared to incandescents. Batteries have fallen at 20% annual rates. That has made possible electric cars. So in less than a decade, we've gone from electric cars being a kind of a dream to it's knowing that it's going to take over the world in the next decade. Similarly, batteries are making possible solar-powered energy taking over a large proportion of all electricity generation. LIDAR makes possible much better self-driving cars. The internet has changed our lives, as has cellular, and they've all changed at astonishing rates. So, we've got all these rapid price declines. Is this how we should think about real intangibles? Or are 2% of the economy that's devoted to very narrowly to R&D, should we think of that as deflating at a 10% or 20% rate, and that it's actually adding 0.2 or 0.4% to GDP growth? I don't know, but these are tough questions. There's a great deal of research that needs to be done, but there are pathways by which we can measure these outputs of R&D, as the National Institutes of Health have done in measuring the rate of decline of sequencing human genome. And all these things are very important. Anyway, there's definitely been rapid progress in a bunch of these areas. It's possible that some areas could be deflating at double-digit rates. I think whether we want to use rapid deflation in intangibles is an open question. And the question is, do we want to draw a strong parallel with tangible investing? Maybe if we do, we should deflate intangibles at a rapid rate. Okay, thank you.
Take this off. It's a very interesting and fun paper to read, with especially all those facts about dramatic innovations bringing down the cost of everything from space launches to biology. So just to summarize, what I take away as the main point here is that Leonard is trying to argue, if you did a deflator properly for a lot of these intangibles, you would see it dropping fast. And the argument is based on how much does it cost to launch an aircraft into space? How much does it cost to sequence a human genome, and so on? He had training an AI algorithm in there, performing a chemistry experiment. So the amount you could do in a unit of time all dropped dramatically. So I view this as kind of an extension of the approach Nordhaus took years ago when he said, how much does it cost to produce a lumen of light? I like these sort of outcome-based measures. That's a chart from Nordhaus's paper there on the cost of a lumen since 1800. So effectively, the argument is we've seen large price, the cost of the outcome must have dropped dramatically. So there should be large price declines in the assets that embody these intangible R&D. And that implies rapid obsolescence and therefore a high depreciation rate. So paper doesn't quite do the dollars per lumen type calculation, but it's certainly, if they did, you'd find something that looked a lot like Nordhaus's calculations, particularly if you add LED to the end of Nordhaus's series. The question is, if you do this rapidly falling deflator for intangible investment, we're going to get a lot of growth of intangible investment. The stock is going to become extremely large unless you also think about there should be at the same time a high depreciation rate. The argument is lots of investment means fast obsolescence, and the fast obsolescence means a lot of loss of value from the old stuff. So to keep the stock within reason, we need the two to move together. So one sort of takeaway, if you're doing national accounts, I mean, in general, I think when you see a big investment boom, there's probably more retirement of the old stuff. So there's a link we might want to think about in national accounts. This is a very nice paper, an important topic, lots of fascinating examples. I would say one comment, the examples don't quite get all the way to what Nordhaus would call a tectonic shift, where there's a revolutionary change, but a lot of them come pretty close to that. So really big advances with dramatic reductions in cost. I would say we can't really base our depreciation rate in national accounts off of that sort of thing. They're rather irregular. They're actually, if you read the description of big things that happen in infrequent and rare events, it looks a lot like what they call other change of volume of assets in the SNA. So I'd put it more maybe into the holding gains category, something like that, at least part of it. Because what we really want is some kind of, instead of ex post loss of value, what's a reasonable expected rate of loss of value? And also we need a certain amount of stability in our assumptions in national accounts, so we can't have dramatic revisions in this number all the time. Another sort of comment on the paper, and I guess if Leonard keeps working, could take this into account. The paper basically just has one price index, and we're inferring two things from one index. But if you do the way they do the tangible asset accounting, there's an age price profile that gives a rate of depreciation. So they look at the used asset price relative to a new asset price. And then there's another index, which is the price change for a new asset over time. Here, there's one index which seems to be answering two questions at the same time. I'm not saying that's wrong. I think Leonard can explain how it works, but it would be useful to discuss this. Basically, maybe the reservation price of the new technology asset would give you the price change for the new assets, and you'd have some kind of inference about what the market equilibrium price of the old asset would be at the same time. But it would be nice to close the link a little tighter with the way we do tangible asset accounting. So that brings me to the end. I guess I'll leave it. Well, I'll leave it for the next person. And I really enjoyed the paper.
Thank you very much. Dan, and then Josh.
Thanks for a really interesting, provocative paper. I hesitate a little to ask this question, just a 15 seconds of history. Leonard was my teaching assistant, first year graduate macro. So I'm always intimidated by asking Leonard questions, but let me go ahead and do that. Let me go ahead and do that anyways. So in thinking about these categories that you highlight in these examples of incredibly rapid change, I'm trying to think about the split between what we think of as intangible capital inputs and what we think of as multi-factor productivity and so on. And I think this touches back on the conversation about, do we think of intangible capital as rival risks or non-rival risks? And in a growth accounting context, how do we want to capture this? As I think about some of the examples that you offered, it seems like a lot of it might be what we would have traditionally called R&D, and that the capital that went into them, tangible or intangible, maybe it deflated fast, maybe it didn't. But the real thing that changed is people figured out better ways of doing, say, gene sequencing. And so I'm struggling with just how should we think of it's the same issue that we talked about earlier. How should we think about what's rival risk capital, what's non-rival risk capital, what's innovation that we put into the R&D category? I'm sure you've thought about it. Would love to hear any quick thoughts on best ways to how you're thinking about sorting that out.
Well, really, at this stage, I'm mainly just raising these questions. I think that, this stuff that Quarterman Eaton are working on, and that I talked about in a research and income and wealth paper about scientific revolutions in economics, are, about the fact that there's a permanent contribution of R&D, of knowledge to the world, right? And we have this interesting economic system that right now is providing god-awful rewards to the big winners in this space. And that's odd if you think about it, that really, I'm emeritus, I'm doing this for free, right? It's a lot of fun to be a creator, to change the world, right? The best way to predict the future is to make it, right? Do we need these incredible rewards? And what's the relationship between our private rewards and the public benefit, right? And, and that Dan's work on household innovation goes to the heart of this. And so that's ultimately the conundrum that I want us to be thinking about, that innovation is very much a public good ultimately, right? Temporarily, it's a private good, but ultimately it's a public good. And so that's what underlies part of this thinking. And the other thing that underlies part of this thinking is that people look at our data and they say, oh, we're not growing fast enough. And I think that that's crazy. I think we're growing way too fast for our poor little brains.
Thanks very much for that, Leonard. I just wanted to play back to you something that you said to me a couple of years ago.
Oh no!
On the same vein, and I find it easier to get my head around that than that. You said to me, if software is depreciating at a rate of 20 to 40% in the national accounts, and if businesses, why is software depreciating so quickly? Because of obsolescence. That must mean that businesses are discarding that old software and replacing it with some new software, which must mean the new software is substantially better than the old software for that to be warranted. So if depreciation is at 40%, does that mean that quality change is at 40% and therefore price change should be at minus 40%? And I find that link between depreciation to quality change of the new replacement assets to the price index easier for myself to get my head around it. I wondered if you wanted to comment on that.
Well, it sounds like I should have written this paper 2 years ago. It would have been clearer. But yes, I mean, I think that even with a lot of machinery, right, where it's much trickier to try and figure out whether something is really wearing out or becoming obsolete, right? There's this underlying idea that, in fact, a lot of machines can last practically forever if they're maintained correctly. But you stop maintaining the thing precisely because it's become obsolete and you want to replace it. So, there's a similar problem with all kinds of tangibles. And we don't know the depreciation rate of tangibles either. I mean, we call it GDP rather than net domestic product, not because we really want to measure gross domestic product, but because we don't trust our depreciation rates.
Great, thank you. We have a couple of comments from people watching the live stream. One from Rachel Solovacek and another from Sanjeev Mahajan. Their comments, so and I know Martin had a question, so I'll just read out Rachel's comment. It says, I'm not sure that discarding old stuff means that it was bad. For example, video games depreciate after their target market plays it and gets bored. And Sanjeev has a longer comment. Sorry, Sanjeev, we'll get to it later. But maybe, sorry, Sanjeev,
right.
But maybe Martin?
Martin Wheel from King's College. I wanted to ask whether you have any thoughts on what the R&D is conferring in terms of consumption benefits. If you think of Nordhaus example, he showed lighting becoming very much cheaper. And lighting is a consumption good as well as an input into the production process. But how is sequencing the human genome a consumption good? Or are you saying you expect there will be benefits, there may eventually be benefits from that, but they're further down the line in terms of improved health and so on?
Well, I mean, so one of the most important things that we've done in facing the pandemic is to understand mutations of the coronavirus. And we've been able to track those mutations because of this sequencing technology having gotten so cheap, right? We've sequenced millions of, coronavirus genomes, and the out-of-pocket cost of those things is in the pennies as a result of, if you look at the cost per megabyte of DNA. So, we already see those benefits. We already saw the benefits with the fact that they were able to develop Moderna's mRNA in 3 days after they got the DNA sequence. It did take over a year to fully vet that, but we've benefited big time. What were those things worth to us? Trillions of dollars.
Great. Sorry, we don't have any more time next time. Thank you very much, Leonard and Marshall. Now we'll switch to Thomas, who will be doing this virtually. Thank you, Thomas.
Okay. Hello, everyone. I hope you can hear me well now. Thanks for having me virtually at this conference. This paper on intangible capital indicators based on web scraping of social media is joint work with colleagues from the IARIW and the University of Zurich. So what's the motivation for our paper? Okay, so I clicked on next on my remote, but it didn't work. Or did it work? Okay. Okay, it's just move on. Okay, so the motivation for our paper is that knowledge-based capital is considered as a key factor for productivity growth and dispersion. Just to mention 2 papers. One is by Roth and Sen, which is part of the Global Into project. They just provided a very nice overview on the recent papers on intangible capital and labor productivity growth. And there's also a paper by Carol Corrado and co-authors. They are focusing on the productivity dispersion in their OECD working paper. So we all know measurement of knowledge-based capital is challenging, and the two papers in this today already show that. So especially the one by Josh. So from our point of view, so measuring innovative property and computerized information is not so complicated because it's well covered already in different statistical surveys, but comprehensive statistical data on economic competencies is rather scarce. So that's the reason why we focus on the third type of asset type, the economic competencies, and in particular we focus on brand equity and firm-specific human capital. And to be honest, so this decision on focusing just on brand equity and firm-specific human capital is just driven by data availability. So we don't say that organizational capital is also very, very important, but we are not able to find a data source, platform-based data source for our work with respect to organizational capital. So it's the reason why we focus on firm-specific human capital and on brand equity. So just mentioning the objective of the paper. So we want to develop a new way of measuring intangible investment, especially in economic competencies that do not require firm surveys. And the principal advantage of this approach is that we have a broader coverage at lower costs. We have much higher timeliness, and we also can have a much higher frequency. So in doing that, we develop a method that semi-automatic links business survey data with platform data, and to explicitly develop the non-monetary indicators based on the platforms. We rely on on data from Facebook. There we just focus on brand equity, which is just based on the measure on the number of likes a company has on Facebook. And the second data source we use in our paper is the employer branding and value platform Kununu. So there we have information on brand equity and firm-specific human capital. So the information there is just the ratings for the company image and the ratings of employees on the job training and career development. Just a side note on Kununu, on the platform Kununu. So that's a very popular platform in the German-speaking countries, and it's more or less a competitor of Glassdoor, which is probably more better known in English-speaking countries. And the third step in our paper is we validate these indicators that we get from the platforms by comparing them with survey data from the MIP. MIP is the Mannheim Innovation Panel, which is the German contribution to the Community Innovation Survey. And in the MIP, we use different types of data. So the first type of data that we use from there is we use the company name and the URL of the company, but we also use measures like turnover, the number of employees, and the industry code. And we also, for the validation of the indicators, we also use the expenditures on marketing and the expenditures on training. Okay. This graph describes the methodology that we use to identify the platform profiles and download the data. So we start on the left with information from the Mannheim Innovation Panel. So there we have the URL of the company and the company name. Then we do a standardized Google search with the info of the company, the name of the platform, and just restricting them to the URL of the platform. So this is done in Java with the Selenium package, and we always get the Google search results from that and can download them. And what we do then is we download the first page of the search results, and link these company profiles on the platforms with our survey data that we have from the Mannheim Innovation Panel. And it's not always clear that the first search result is also the correct firm profile. So we have to check these matches automatically and manually. But after we are sure that the profile page really corresponds to the company in the firm survey, we download, we scrape the whole platform, the whole company profile on the platform, and also pass the information from that data. Okay, so to give you an example how this is really done, so we start at the first step. We start with the information from the Mannheim Innovation Panel. So there we have the company name and the URL. We do in the second step the Google search, and then we download the first page of the Kununu platform profile of this company. In this case, it's SAP. And then we validate whether we really found the correct company profile. And after we are sure that it's the right company profile, we download in the fourth step, we download the ratings for the company image and the ratings for the for career development and further education. So these ratings, just to mention it again, these ratings are provided by former employees and current employees of the companies. So they are able to rate their own employer or their ex-employer. Okay, so what's the outcome of this whole approach? So we started with about 7,500 companies from the Mannheim Innovation Panel, did this Google search as described before, and the outcome is that we found about 2,000 Kununu profiles, that's 28.2% of all companies, and 1,500, about 1,500 Facebook profiles, that's about 20% of the companies in our Mannheim Innovation Panel. And to check whether it's really the correct firm we downloaded, we did for Facebook, we used an exact match of the company URL because the companies are required to provide an URL on their Facebook page. And for Kununu, that's not the case. So that's the reason why we have to do a string matching of the firm name or if there's no exact match found, we perform a fuzzy string matching. Okay, so coming to some descriptive statistics. So what you can see here are 3 tables of descriptive statistics. The first one is for the first 2 ones are for Kununu. The first one is for Kununu, the Kununu rating on training. The second one is for Kununu rating on company image, and the third one is for Facebook. And it's a mixture of the platform data and the information that's available in the Mannheim Innovation Panel. And what you can see in the first 2 tables is that the number of observations in our estimation sample is reduced to 500 to only 500 companies, and we found about 2,000 companies in total. But the reduction of the number of observations is driven by the fact that we require a certain number of ratings for each company, because if the number of ratings is too low, there's just too much noise in the data. So that's the reason for this dramatic reduction of the number of observations. Okay, so our third step was actually to validate the information we have on the platforms with data that we have in the Mannheim Innovation Panel. And in doing this, we used just a standard ORS regression, and we analyzed the relationship between the indicators for brand equity that we find on the platforms and the survey-based measure on the expenditures on marketing. So for brand equity, we have 2 different platform-based measures. So the one is the number of Facebook likes, and the other is the rating on Kununu. And we regress this on the expenditures on marketing from the survey from the MIP survey, and a set of control variables. And we do the same for firm-specific human capital. There we only have information from Kununu and no information from Facebook. So what's the outcome for these regressions? So in the first 2 columns, you see the regressions for firm-specific human capital. And in the third and fourth column, you see the results for the company image, meaning brand equity. So for training, we only see a borderline significant relationship between the training expenditures of the firm and the indicators on the platforms. So the relationship is not very strong here. But in the third and fourth column, you see that there is a highly significant correlation between the survey-based marketing expenditures and the Kununu rating for the company image, which means brand equity. So there seems to be some kind of information, some valuable information on the platforms. Doing the same for Facebook, as mentioned before, for Facebook we only have a measure of brand equity and not for firm-specific human capital. So the dependent variable here is the number of Facebook likes, and our main explanatory variable is the survey-based information on marketing expenditures. And what you can see here is again, there is a highly significant correlation between the survey-based marketing expenditures and the number of likes, meaning brand equity on the platforms. So it seems that for both types of intangible assets and for both platforms, there seems to be some kind of valuable information on the platforms. And but the correlation is higher for brand equity than for firm-specific human capital. But actually, our overall goal was to really predict expenditures on training and on marketing based on this platform data. So that was actually the overall goal that we had in this project or in this paper. And we did this by using some machine learning approach. The reason for that is that the machine learning approach is more flexible than just prediction based on linear regressions. And yeah, that's the reason why we did machine learning. And we used, so in doing that, we used 4 different machine learning approaches, used neural networks, random forest, k-linear neighbors, and support vector machines. And we checked whether the predictions are valid, and the indicator whether our predictions are good or bad is just the mean absolute error. And what I'm going to present now is the outcome of the machine learning with the Facebook data. So in the last column, you see the mean absolute error. And in the first 4 columns, you see the different types of features or inputs. So we have, in the first row, we have just our platform-based indicator from Facebook. And in the other rows, we we add more features. So the number of employees, turnover, industry, and our Facebook-based indicator on the company image. And so the baseline result is that the mean absolute error is at 0.27. Adding just the image indicator from Facebook reduces this mean absolute error only slight to 0.26. And when we use all the features, meaning the information from the platform and the number of employees, turnover, and the industry classification of the company from the Mannheim Innovation Panel, we can reduce this mean absolute error to 0.21. So overall, there is some information on the platform profiles, but the mean absolute error is still very high, and the additional information on the platforms is rather low. So predicting expenditures on firm-specific human capital and brand equity just based on the platform-based indicators that we just developed is not really an option. And our guess why this is the case is that we are just lacking a reasonable number of observations. So we're just about using 500 to 1,000 observations, and for doing a machine learning approach, that's just not enough observation, because we also have to split it into a training and a test data set. So the number of observations is just very low. So to conclude, so we were able to derive basic indicators for brand equity and firm-specific human capital from the platforms Facebook and Kanonu. When we compare these indicators with OLS regressions, we find a significant relationship that is higher for brand equity. We did various robustness checks to confirm the validity of the results, but our overall goal to use the platform indicators to really predict expenditures for training and marketing, that didn't work very well, to be honest. So the machine learning approach was not really successful. And the reason for that is that we are just lacking a reasonable number of observations. So that's the main reason for that. Okay, so it's 15 minutes are over. That's all I want to say. Thanks for your attention, and I would hand over to Charlotte Meng for the discussion. Thank you very much.
Thank you, Thomas. So as you said, we'll hand over to Charlotte now. Thank you.
Can we skip to my slides? Yeah, great, thank you. Hello, everyone. I'm Charlotte. I'm a research associate at ESCoE. I work with Rebecca Riley and Paul Minson and other colleagues on management and expectation surveys, which is the reason why I'm here for the intangible asset research. And I also work with a colleague to investigate business responses to COVID using web scraped data. So that is why I find this research particularly interesting. To summarize, this is a very interesting and innovative research. It uses new thinking to develop measures for intangible capitals. I think one comment I'd like to add to Leonard's comment this morning, that we are drowned in a sea of knowledge. The other side is that we're also drowned in a sea of data now. And we really need to think very carefully how to make good use of the data rather than the bad one. But there are certainly very useful things in this data. And Thomas and his co-authors is pushing forward in this direction for sure. So my comments are in three aspects. The first comment is that as he has rightly pointed out that the representation of his sample is probably not balanced. He said that he had overrepresented medium-sized and large-sized firms. That is one. And I would think that the other two sampling issue is that first, maybe in sector, hospitality face customers more than manufacturing sector. So if he used Facebook or Kununu, there are more ratings probably for service rather than for manufacturing. And the other is that because he used web data, probably on the other side, the customer of those websites are more likely young people rather than elderly people. I did a search online and you can see that the usage of Facebook declined with age. So those ratings he developed is probably a reflection of young people's opinion rather than the whole population. That is one. I recognize that it is hard to deal with the presentation problem using web script data. It is hard, it is a challenge, but probably the authors can explore a bit more by looking at the distribution of his around 600 firms and see how are they distributed and the different maybe scores for different sectors or different sized firms. That is one comment. And the other one is the presentation, the precision of his measure. So looking at one aspect is he used that the likes of Facebook to look at the brand equity. I see that there are a number of different research using Facebook data and they're using more than likes. For example, they look more at the engagement of the customers, looking at the repost and comments sharing. Probably that is more reflective of how customers look at the company, because you can imagine a scenario that someone goes to the Facebook fans page and he clicked like and then he disappeared. But if you look at more at the post and at the comment and shares, that shows more about their engagement with the firm. The second one is that when he look at company image with Kununu data, you can imagine Kununu are ratings from employers, they're not customers. Employers may look at the company differently than, from a customer. That is different from probably the normal sense of brand equity. And I would think it's very interesting if we compare this brand equity measure from Kununu, probably with brand equity measure with Facebook or survey. I think they shows different aspect of brand equity because they involve their employees, sorry. And the third general comments are about maybe the presentation of the paper or future research. One thing that rings a bell when I read the paper is that the last section when he tried to predict companies' expenditure on marketing or brand equity, he find that the predictive power of the two new measures are not good. So I think probably the authors can explore a bit more, maybe by develop a index throwing in Facebook likes or comments, or perhaps using new models. But I just think that the negative results probably need a bit more explorations. And then I think also, yeah, if he can, I know it's a challenge, but if he can explore the data in a panel way, probably that's more useful, because now the Facebook data is accumulative throughout the years, while the innovation panel is a reflection of the expenditure in that specific year. Therefore, it's not comparing apples to apples. So if we can find panel data, that would be very useful for sure. And the last one is that I think maybe he can emphasize a bit more about his contribution and contribution to literature in the paper, because now it is not very clear to me in that paper. Yeah, so that's my comments. Thank you.
Any questions? Thomas, would you like to respond to any of Charlotte's comments?
Yes, I can. So overall, great comments. A lot of the things you mentioned, we also thought about. So our earlier approach was actually to really not use just Facebook likes, but also look how much of the posts on Facebook are shared by the customers. And but the reason again was that most of the firms are rather small that we have in our innovation sample, and there is not just not that much engagement on the platform. So we cannot think about a multi-billion company that really has a few 100,000 Facebook followers, and there's not a lot of posts on the platform, and that's the reason why we didn't do that. The other interesting suggestion was to explore the panel dimension. So that's one thing we really considered, and we probably will do that, because the Mannheim Innovation Panel asks this information on expenditures on marketing and firms and training every 2 years, and we more or less have the panel information, and we have the information on Kununu back to 2010, and we also can use the Facebook Graph API probably to get the Facebook likes for the history of Facebook likes of the companies. So exploring the panel dimension is something that we really thought about, and but the overall problem is just that we still don't think that we really have enough observations to really prove that our predictions are really helpful, and it's so the overall the goal of the paper was more of explorative nature, and we're still not sure how to proceed from here, whether we should just say, okay, it was a check, we tested it, and that's the results, or we would try to revise the paper and add some new ideas. That's something we're not really decided on.
Great, thank you very much. Anyone, any questions? So I'd just like to add to the sample selection issue. It is an issue, but if you don't try, you will never reach the conclusions and figure out that it is an issue. I think for me, just looking at the Kununu survey, that it is employees responding to it, you may get a sample selection within them as well. For example, if they gave bad reviews, I'm not saying anyone would, but if you did, if you were a former employee, then that would just add to the issues. Anyone else? Great, we have 3 minutes. So if you had questions for any of the other presenters, should we give you back 3 minutes of your life and time? Fine. Thank you very much, everyone, for participating, to the presenters, discussants, and to you. It's been a great session. Thank you very much.